Hello, people. We are here again for some exciting mathing algebra. Yay! We're going to do section 12.4 on page 794. Great news, there's no graphing. All right, section 12.4, page 794. Okay, last week we talked about excluded values. You guys test those, like you solved for something and then you plugged it in to see if it worked, or there was also some times where the bottom of the fraction, whatever would make it equal 0, would be an excluded value or one that wouldn't work. So we're going to do some more of that today. So I want to review that first. So if I have to find the excluded value of something, what that means is what number plugged into the bottom of my fraction will make that part equal 0. Okay, so example 1a is x plus 8 over 10x. So I always, in my problems, I always find the excluded value first because you're supposed to do it with the original piece, not the simplified version, okay? So to find the excluded value, I say, okay, I take the bottom of my fraction, which is 10x, and I have it equal to 0. What will I be able to plug in here to make it equal 0? Some of you will be able to tell right away. If you can't tell right away, just solve this equation. Divide by 10, and x would be 0. So my excluded value would be a 0 for 1a. That's what plugged in here makes the bottom equal to 0. Let's do b. My equation for example 1b is 5 over 2y plus 14. Again, some of you will just be able to know what should go in there to make it equal 0, but if you don't, you just take your bottom equation and have it equal to 0 and solve. So we're going to subtract 14. 2y is going to be negative 14, and then we'll divide by 2. Y is going to be negative 7. So negative 7 is my excluded value because that's what I can plug into here to make the bottom equal 0. Okay, let's try C. Okay, C. When we do excluded values, we just deal with the bottom of our fraction. So I'm only going to write that this time. V squared minus 9 is the bottom of our fraction. And I need to know what in the world can I plug into there to have it equal to 0. Okay? So some of you will want to add 9 here. V squared is going to equal 9. Now, how do I get rid of a square? I have to square root. Remember, when you square root of 9, the answer is either plus or minus that, right? So your excluded values on 1C is the one that we are doing. There's actually two. A positive and a negative 3 would both make the bottom of that equation equal to 0. Okay, let's look at D. D looks a little super crazy complicated, but don't worry, I will help you. Okay, I'm just going to write the bottom because that's all we're dealing with when we're doing excluded values. 8w squared plus w minus 5, I think is what it says. Yeah, oh, plus 5. Okay, so when it looks like this, what I'm going to want to do first is I immediately go to factoring because that's when I see it in a quadratic equation, I immediately do that. But to save yourself a little bit of time, when you have a quadratic equation that you're needing to make equal 0, you can solve any of the ways that you want to, is fine. But I always test it first using the discriminant. Remember, this is the discriminant. Remember, in my discriminant, if my answer is a negative number, I'm not even going to have a solution. So instead of trying to factor this straight away, I'm going to go ahead and test it and make sure I'm even going to be able to get an answer. If not, I can just put no solution and move on to the next one. So it's kind of a little check to see if we have to try and factor it even in the first place. So b squared, b is a 1, minus 4 times a is an 8, times c is a 5. I immediately know that this number is bigger than 1, right? Whatever this crazy thing is. So my answer is going to be a negative number, right? Remember, if I have a negative number for my discriminant, there's no solution. Let's review. If you do a discriminant and your number is bigger than 0 when you're done with your discriminant, there's going to be two answers. If your number is equal to 0, there's going to be one answer. And if your number is less than 0, like mine is here because it's negative, there's going to be no solutions. So immediately, I don't even have to try and factor this. I see it's going to be a negative number, so no solution. I can move on. There are no excluded values. Okay? All right. Let's move on to example 2. I'm just going to leave that there because it might be helpful for us later. Okay? Example 2 says we're supposed to simplify, if possible, because some of them are already as simplified as you can get, and we're supposed to state the excluded values. So I'm going to go ahead, even though it says the excluded values as my second set of directions, I'm going to do those first because you're supposed to do those before you simplify it, okay? So 2a is r over 2r. So my first thing I'm going to do is my excluded values. What makes the bottom of this 0? Remember, if you don't know, just have it equal to 0 and solve. 0, that's 0, right? So my excluded value for this problem is 0. Okay, that could be the first thing I write down. Now I have to simplify. So because everything is being multiplied with each other, I can cancel across the division line. So r over r would be 1. Okay, I fill an empty space with a 1 and I still have a 2 on the bottom. And I'm done. Simplified to 1/2. Okay, so my excluded value, maybe we should label that excluded value, is 0, and my solution is, my simplified version is 1/2. Okay, let's try B. 2b. 5x over 5 times x plus 2, I think is what it says. Okay, so first of all, I like to do my excluded value. My excluded value is whatever makes the bottom equal 0. Well, what could I plug right in there that would make this equal to 0? A -2, right? So my excluded value is going to be -2. And now that's taken care of and I can move on. Okay, my 5 over 5 can get canceled. Now, this is super tricky and I hope all of you are listening to this. It's important. This x is stuck adding to this 2. So because there's an addition situation right here, I cannot cancel out these 2 x's because this number that belongs in this parentheses is really whatever x is plus 2. And this is just x by itself. So they're not really the same number. So I cannot cancel those ones out. So if a variable is stuck being added or subtracted with another number, it cannot cancel out with a variable on top. Let's just make up a number for x. Let's say x is 4. 4 plus 2 would really be 6 down here, and this would just be 4. That's why you can't cancel it out, okay? You can only cancel out things if they're being multiplied, all right? So I canceled out my 5s. My simplified version is this, okay? All right, let's move on to example number 2, and we're going to do letter C. 6m to the 3rd minus 12m to the 3rd, I think, is that right? Yes, over 18m squared. Okay, my excluded value first is what I like to do, remember? So what would I plug in here to make the bottom equal to 0? Anything times 0 is 0, right? So my excluded value for letter C is going to just be 0. I'm going to get that taken care of. All right, now, things that we want to do when we have multiple numbers on top is try and factor something out. So I know a 6 will go into both of these, but I also know m to the 3rd will go into both of them. Did I copy that down right? Oh no, see, I thought that was wrong. This is really a 2. All right. I know 2, right? Only 2 of these can I take out. 6 will go into both of these numbers, and 2 m's will go into, m squared will go into both of those, right? So I'm going to factor that out. So 6 divided by 6 is 1. I had 3 m's, I took out 2, so I have 1 of those. 12 divided by 6 is 2. I had an m squared, but I took it out, so there's nothing left, so it's just m minus 2. And that's going to be over 18m squared, okay? Now that I have factored everything, I can start canceling things out, okay? Because these are multiplying, I can go ahead and get rid of my m squareds, right? They can cancel each other out. I can reduce 6 over 18. 6 over 18 would reduce to 1 over 3.